All right, let's talk about some of the things that could be better than actually what Volkswagen created by beating their engineering. And a lot of people will disagree that that can be done. You got to remember, when you're building a car, there's always a budget that they're trying to meet. And sometimes the better engineering ideas were not in line with the budget that they were trying to create. And so a lot of engineering stuff might have gotten put aside when maybe they had a better idea, but it didn't meet budget. Let's talk about some of those things. Some of the guys who beat the engineering of Volkswagen were like Daryl Vitone, Joe Vitone, Dean Lowry, Gene Berg, some of the big people in this, for years. I'm trying to think of the other guy, Bob Hoover. He figured out how to beat their engineering in a lot of ways, and today I believe that there's a good possibility that you can beat the engineering of the Volkswagen people because of all the experience of all those people all put into places. Like, one of the things that I think beats the engineering of the original car is the cases. The old cases were all made from magnesium. They also have aluminum cases, the Autolinea cases. Most of them are made by Autolinea, even though they have different names on them. Those Brazilian cases, they're made out of aluminum. Aluminum is a denser material. It doesn't expand and contract as much. It doesn't flex as much as the magnesium. So a lot of ways, I think aluminum, even though it is heavier, can be a much better case to start out with if you're building a new engine. And let's say you need a new case, I would always go to the aluminum case for a few different reasons. One is you can get the size of the engine that you want to build if you want to build something over the stock size, if you're going for any kind of performance. The other thing is that you have a denser material. You can put in chromoly push rods in it, and a lot of times when you're running chromoly push rods with the mag case, the expansion and contraction of the case, sometimes you'll notice, like I'm driving one of my buses has an aluminum case and one of them has a mag case, and I noticed when I drive the bus with the mag case, after I've been driving it a while, that the lifters start to get a little bit noisy, and then when it cools off colder, they don't make as much noise, and that's because there's that expansion and contraction of the case and movement. So movement causes wear, and typically your wear on a Volkswagen is because you have opposing cylinders. You have this cylinder here and the one over here are moving opposing to each other, and wear happens in this section of the case. And this is learned a lot by people who are doing racing. So a lot of stuff is learned from racing, even in every car, especially Volkswagen, because racing kind of magnifies the issues that you might have. Another thing that's, again, probably was not meeting Volkswagen's budget was using counterweighted crankshafts. The counterweighted crankshafts spin so much better than the other ones. To me, it was just a better idea. When you have weight on the other opposite of where it's firing, you end up with less issues with wear, and it tends to spin RPMs better. People have figured that out in the aftermarket engineering. And those counterweighted cranks, especially and even though they're made in China, a lot of them are, the counterweighted 4340 cranks are really good for a long life engine. I have a friend who's got a aluminum case, 1776, and he's gotten more than 150,000 miles out of an engine without doing too much to it. He was running all aftermarket, a lot of it's Chinese made parts, and they actually worked very well and lasted a long time. So the 4340 counterweighted crank, AA performance heads, and a aluminum case. AA performance heads made in China. So they are upgraded. So what they do is they put a larger valve in. And some people could go, well, I don't want larger valves because I lose bottom end. And the way to combat that is to, when you order the heads, you order them to a larger size. And if you can, put in the counterweighted crank so that you get a, if you're doing a complete rebuild and you need a case, you can go with that larger engine so that you don't lose the bottom end. Put the larger valve heads on that have better airflow. A couple of things they have on them. They figured out, you see that casting there? You can see that down in there, how there's a little bit of remnant on there. What AA's performance heads do is they try and make sure that those openings are really good, and you should check them yourself as well. This is a dual port head from Mexico. If you see that one's there, it's kind of, it's not really opened up very well. And same thing over here. You know, those are the types of things you should be looking at when you do your own rebuild, that you can actually beat the engineers. And some people say, well, the Volkswagen ones were better casted than even the Mexican ones. Well, you know, in some ways they were, you know, but they still weren't nearly as good as a performance heads that they make now, with the big valves already in them. So you get big valves, and for today's fuel you also get stainless steel valves, and the stainless steel lasts better with the types of fuel we have now, unleaded. And so back then when they made these, again, they had leaded fuel, so those things have changed. And a lot of us are running performance cams, so the AA performance heads, you can order them with the single high rev springs, which are improved and better for the higher revving engine, so you can get a little more RPM out of your engine on the freeway. That also helps with longevity of your engine. The things in the aluminum cases that are really nice is the aluminum cases are already made. If you see here, there's an O-ring between here to stop the leak. What they do on the aluminum cases is they actually have something called a shuffle pin. You know, if you look at most newer cars, they have like a little sleeve where you put two halves together, like where you put your engine and transmission together. There's a little sleeve that they slide together. That's basically what a shuffle pin is, and they put them on all the cylinders. I believe they have it on all the studs. So you get shuffle pins on all your studs, case studs, so there's less movement. So again, when you have opposing cylinders, there's very, very slight movement like this with the case, and it's just microscopic, but it causes wear on your center main. So typically where you're always looking at when you go to rebuild your engine is your center main to see if this is shiny. Then a lot of times, you know, you bolt it together and you'll have a little bit of a gap in there, then that case is no good. So those are some of the things to look for when you're doing a rebuild. The early magnesium cases, like this is a 40 horse case, but just for example, the early magnesium cases had single relief and a smaller port inside here for the oil, or they call it the gallery, some people do. But the oil galleys and the galleries were smaller, so they didn't have as good a flow. When you have a larger hole, you have less resistance, right? Remember plumbing, a smaller hole, more resistance. And when it goes through there, because there's more surface area around it, when you have a larger hole, there's less resistance. So what they did is they had larger oil galleries, and they also had, some of them had on the number 3 cylinder, this is number 3, this part would be factory blocked in. So the cases that had that, I think, were the AF. You have to really look at them. German case, or the AS41, I believe, is also, if you look at those. Sometimes the AS41 German were blocked in right here where the number 3 is, and that was a prone area to crackage. So if you're getting an aluminum case, or you're going with a mag case and you're trying to do anything, you know, you want a really strong engine, you want to beat their engineering, then you want to make sure you get the one that has the blocked ends area. Some people welded them in. They had a welded number 3, they called that, and those are good too. So there was a lot of different ways to block in that number 3 to make it stronger. The best one is the AS41 German, I believe it was, and it was actually just a nice big block of magnesium in that area, and those ones are really good to build. So I actually have one of my engines, my 1904, is built with that that case, and only had one machine on it. So I was really fortunate to get a case like that. The other engine I have, which is the 2007, another good bulletproof engine I call it, has the aluminum case. So the aluminum case actually engine is quieter than the other one because there's less movement, because of the material used, and less movement in the valves, less movement in all the areas, because I have upgraded heads, and I have the chromoly push rods, and I have an aluminum case. All those things all kind of work together to keep the engine from that volumetric efficiency being at the best rate, because of the materials being aluminum versus magnesium. Another way I believe you can beat the engineers is, and all people, again, they tell me that this doesn't work, and there's a bulletin out from Volkswagen that said that this doesn't work as good. Again, a lot of stuff's created because of budgeting, okay? And if they're never going to say they're wrong, because if they say they're wrong, then there's lawsuits available. There's a lot of different things that can happen. Is on the bottom of your engine, originally they had, type 1, they had this type of a thing here for the cooling. Now if you notice that there's a large area here where the air goes through. Now if you know that much about VWs, you'll know that when number 3, which is always the hottest cylinder there is, tends to, when it blows a piston out, it usually blows it out right in this area. So number 3, when it goes, you almost always check it. It's near this stud, and it'll, you blow your piston out because it overheated. And I believe a way to actually combat that. Well, originally you had your other tin that goes underneath here. It goes like this and kind of goes around, and then you're supposed to have that little short one. And you notice a lot of people are missing that little short piece. So if you have all the original stuff on it with the piece that goes around and the little short one, it isn't a bad design. It was actually really good design. It works pretty well. But again, if people were missing one of those little pieces, then it's kind of pointless to have this system. What you can do is use a Type 3, which eliminates that. This is a Type 3 cooling system. The Type 3 had these little deflectors here to help the air go around the heads better. It had a metered hole on each side so that they were getting the proper cooling for the engine for the Type 3, because the Type 3 has less airflow. So basically you're taking an engineering idea from the Type 3, because it had an airflow issue and an overheating issue, and you're developing that into your Type 1. And a lot of people say, again, this does not work. We actually tested it back in the old days because we were like really leery on whether it did work or not, and we found that it didn't. That the bulletin was not correct. We actually tested it and found that this ran cooler on a performance engine, especially when you're running a merged exhaust system. Having a little bit of a lighting issue in here because, let me see if I can get you guys some light. But if you can see here, this is a merged exhaust system. These are a huge performance upgrade. That flange, the way that those are going together, and the lengths of the pipes being all the same, helps get the exhaust flow to be so much better. The disadvantages to that are that your tubes come right across here, and that interferes with this system, the original system here. So really, in my opinion, the only way to combat that is to actually use the Type 3 tin. There is actually somebody that makes the deflector piece that actually fits. Again, it's, in my opinion, it doesn't work quite as good as these. These actually work really well. So on almost any engine, in my opinion, these will actually cool it better than the original stuff. And like I said, they had a bulletin out that says that it doesn't work. Again, they're trying to probably protect themselves from lawsuit, and also protect themselves from anything, that would think that they were being cheap by not putting these on a Type 1. And again, there was a company many years ago that people used to sell these as something called Cool Tin, and we found that they did work. We checked it on an engine before and after, and we got several degrees cooler temperature on the same engine. So it was on a 1776, so it wasn't a stock engine. So I can't tell you what it is on a stock engine. I don't know. I don't remember the exact data of what we found out back then, but we found that these did work and run the engine a little bit cooler. So I run this style on most of my cars. A lot of times when it's just a stock engine, it doesn't really make that much difference. So if it's 1600 single port, it might not make any significant difference in the cooling, but I noticed on the larger engines it does help quite a bit, and especially when you're running the merged exhaust, because that pipe goes right along here, it makes it so you can't run those other two tin pieces. So you can't run the one that goes over here, so then you have this large area where the air escapes, and that doesn't help your engine cooling. It makes it run much hotter in this area right here around that stud. So just a couple things to think about if you're building an engine. If you want to beat the original engineers, this is again my opinion. You can decide to do it, not to do it. You can think that Volkswagen's the hero of everything and that they know everything and they're going to be better than everybody. But in my opinion, they always have budgets, and when they have budgets, you know, they're going to compromise to meet that budget, and you know, you can probably do better. I mean, that's why Gene became a business. That's why MP, the original MP, became a business. The new MP is just different. It's not the same. But it's why that they made stuff to be better. Scat Performance makes stuff that is superior, in my opinion, to the original stuff, or at least as good. So the things you could do to improve, of course, upgrade the camshaft. That's one of them. If you're building a new engine and you have a choice between buying a new mag case and new aluminum, absolutely I would go totally to the aluminum. I like the AA Performance heads. I think they're really well made. They actually improved also the spark plug. What they do is they have the spark plug, the areas that used to be problems for us were always between the valve and the spark plug. You get a little crack and your spark plug would strip out. You had to replace your heads at some point. What they did is they also used a peanut plug and moved it just slightly and put it in a better location. But the peanut plug has more, basically it's the one that has the smaller 5/8 open, 5/8 socket that you use to take it out. That's what a peanut plug we call them. And they have a longer thread, so there's more threads on there, and it's a longer, and it gives them more meat right around the spark plug area. So that was a pretty smart idea on those heads. Huge improvement. With that, you also get the big valves. So you have to, so again, if you're building a stock case and you just wanted to improve that, you can go to the 88 thick wall cylinders and get the 90.5 cut heads, and you'll end up with a stock case. You can take it up to a 1679 and have the larger valves, and make sure that when you do that, you make sure that the CCs on the combustion chamber meet what you're trying to do. There's a whole theory of numbers that you got to go through to make sure that's right. The other thing I believe you can do to beat their engineers is use the counterweighted crankshaft. So let's say you're trying to build an inexpensive, you got a stock case that's in good shape. You got a stock case, it's in great shape, line board is good, or maybe you got it line board and you just want to do some things to upgrade that. You can go with a 74 crankshaft, which is already counterweighted. The 88 thick wall heads, pistons, the 90.5 heads, the ones that are already opened up for a 90.5. I don't know the exact opening size. There's, I'm not a machinist. So you go with the 95.5 cut heads. And at the same time, you're going to want to use the chromoly rods because they have more clearance around them. And they're not expensive either. They're made in China, but they actually work pretty good. You got to be a little bit careful putting them together because a lot of times the tangs, where the tangs are on them, you're going to have to do a little bit of work on them to make sure that the bearings fit properly on the crankshaft. So you have to take your time. I have some videos on that stuff on engine building, and you can watch those and kind of get the idea of what to do to make that work out. The only problem you'll run into when you do that, this is why I like to go with the 90.5 pistons, but you'll have to open up your case. to do that. If you use the 88s, you see how these are taller. This is a 90.5 A piston. They have A and B. B is for stroker. More than 74. I believe the 74 works out really nice with an A piston and a short rod. You get the shortest rods you can find, and you use the A pistons, and it comes out with almost no shims. It comes out really nice on the setup. But this is a piston, not 85.5, and what you'll end up with, the 88s are like the same as this. So if you notice, those piston skirts are about, what I'd say, close to 1/4 of an inch too tall. So what you have to do to put those on, you're going to have to be the machinist, get yourself a gram scale, and cut these down. Cut mostly up here, I believe, these skirts mostly. But cut this down a little bit, cut that down a little bit, machine that down, and then put them on a gram scale and make sure that they're all within the proper weight of each other. So you could even take another set of pistons, take the set of pistons that you have, put them on a gram scale, weigh them all, put the weight, write all the weights down for the pistons, and make sure that they're within that specification from one to the other. So, and then cut what you need off of here so that the crankshaft clears. So that's the disadvantage of using the 88s with a stroker crank, is you'll always have to do the pistons that way because you end up with less clearance. So again, if you're building an engine and you have a machine shop close by, or you can send out your case to get it machined, and you go with the 90.5s A pistons, and you want to do that, that'll give you a, let's see, that's a 1904, really nice strong engine. It's really one of the most bulletproof engines. The bulletproof engine sizes are 1835 thick wall, 1776, 1904, and I think 1968, which is a 74 by 90.5. The 78, if you're using an aluminum case, you can go to a 78 crank, and you can go with a 2007, or I think, what's the next size up from there? So it's a 92 thick wall with a 78 crank. I don't know the size. I think it's a 20, I can't remember the number for that offhand. But those engines are all one of the strongest engines. I don't believe going larger than 78 crank that you're going to end up with something that's considered bulletproof. So, like, remember, you have reciprocating weight. Okay, so if you take another 4 millimeters more than the 78 to go to an 82, okay, 82 crank, you're getting more movement this way, and that movement, every time it goes out and turns around and goes back, causes more stress on your engine parts. So, you know, if you're trying to get a lot of miles out of it, you know, it might not be a good idea to go too far on the stroke. So that's why I say 82 is a little bit past that limit of bulletproof. 78 is still in there. 74 is definitely still in there. So, and it depends on the case. So if you're going 78, I would always say to go to the aluminum case, because you're giving back the strength in the case that you're taking away. Because to do a 78 stroker or an 82 stroker on a mag case, you have to cut out quite a bit. You have to take it to a machine shop and they cut out a lot of this stuff. And those supports, you do lose some of your strength in your case. Not that much, but, you know, for longevity, it will, you know, not last as long because of that. So, you know, if you go to the aluminums are already, you don't have to do any machine work to them. They just drop right in. So you can even go with an 82, but again, that reciprocating weight, the movement of all that weight can, you know, cause more stress in your center mains and stuff like that. Even though they do have the shuffle pin, and it still can cause a little more stress and not make it last quite as long. But again, those engines still last pretty long today because of the if you use the aluminum case. With the mag case, you're gonna pay a little bit of a price for that. So that performance. So yeah, those are some of the ways I believe you can beat the engineers. The AA pistons are pretty well made. I think, in my opinion, I don't think there's really a reason to go with the Mahle. With the Mahle piston, I don't think they're really that much better than the AA, unless you're doing. But I think this is where I kind of draw the line. I go from AA to either JE pistons or Wiseco. So if you're going to go really performance, then I believe to just go straight to the real, like these are Mahle, but these are, I think these ones are. These are Mahle pistons, but they, you know, they're better, probably slightly better than the AAs. But like I said, I have a friend, had AA pistons, 150,000 miles on a stock, you know, on a 1776 with a aluminum case. You know, that's like, and driving, and a lot of times he pulls a trailer, so a little trailer with his bug. So you can imagine, that's a lot, you know. And when he got the engine rebuilt, I was like, dude, what's wrong with it? He goes, no, nothing really. I just decided to rebuild it because it's got 150,000 miles on it. I better just rebuild it. I'm like, doesn't smoke, doesn't really use much oil, nothing really wrong with it. He just decided to freshen it up because he was using it a lot. He wanted to make sure it was reliable. And back in the early mag case days, I mean, we were lucky if we saw an engine that went 100,000 miles. We were really going, wow, you know, that 1600 went 100,000 miles. That is incredible, you know. And we used to get 100,000 miles out of most of the engines that we built back in the old days, because the guy I worked with was really meticulous about everything being right, and he wouldn't use more than a 1010 crank, you know, all that stuff. We would, you know, that was it. If it was 2020, we wouldn't run it. You know, back then you could get a lot of brand new German cranks for pretty reasonable, so we didn't bother with anything but just original German stuff, and we get about 100,000 miles. But out of a Chinese engine, 150,000, you know, that's pretty amazing. Brazilian case, Chinese heads, Chinese pistons and cylinders, and Chinese crankshaft, 150,000 miles. So, you know, so people say the China stuff is no good. I don't know, you know, that's pretty well good proof that it does work. There's some Chinese parts I won't buy, some that aren't as good as the others. You know, some of the carburetors and stuff like that aren't as good as the old Webers, but you know, some of the stuff isn't bad. It does work okay. Like I have Chinese brake kits on my cars, even the MP stuff, not too bad. You know, either it fits or it doesn't fit. The ones that don't fit, you're gonna have to do some work on them, make them fit. But typically, as far as braking power, reliability, not that bad. You know, maybe the master cylinders aren't the greatest that they get, but you know, a lot of the actual disc brake parts, not too bad. Definitely work better than the original stuff. So those are just a few things you can look at doing to try and beat the original engineers. And you know, again, do your research, check it out back and forth, look at, you know, reviews on different things, and spend some time. You know, it's worth it. You're going to spend your money, so spend some time on this stuff. But these are just avenues to look at, possibly that you might be able to benefit from and learn from. You know, those are the engine sizes we built that we would consider bulletproof back in the old days. And yeah, there's reasoning behind all that stuff. The reason we wouldn't build a 1914, we wouldn't go with a 94 bore, is because basically when you cut that opening here, you're getting so close to these studs that the case savers are showing through. And you know, that's just not very strong. You're losing a lot, especially with the mag case. You know, with the aluminum cases, you might even be able to go there, you know, and be okay. Because I think they might have repositioned these and used a smaller stud, so you use the 8mm instead of the 10, and they repositioned them so that, you know, you could go with the bigger bore. So using aluminum case and going with a larger bore might be okay. But again, remember, larger piston weighs more reciprocating weight. So If you go with a larger stroke, say you go to that 82 and you go with that large bore, that's more weight moving back and forth, more stress. Those are all things to think about when you're going above the stock engine, trying to make sure that you're in that bulletproof range and not, to that, losing all that. Especially when you're doing mag case, and you start to open up to 94s, and you're putting in an 82 crank or 86. Then it's kind of like what's left of the case isn't that strong. You start to end up with cracks later on, things like that. There's just things to think about. Anyway, some people get away with it. They do it. I think it's like the bulletproof way to go, but in my opinion, you're kind of losing too much, trying to do too much to it. So if you stay in those other ranges, you can have an engine that really runs strong, pulls weight, runs cool, doesn't get hot. So anyway, just a few things I thought I'd share with you guys. I'll talk to you in the next one. A lot of people are just watching my videos for the engine stuff, and I want to make sure that I get a lot of content out for that. I'll talk to you in the next one. Please like, share, and subscribe.